Good afternoon, dear colleagues. My name is Mihail Pahnin. I'm the second-year master student at the European University at St. Petersburg, and today I'm going to speak about a very important question, namely, should natural resources be public or private? On the example of the ocean. This is the joint work with Professor Borisov, Professor Brushin, Professor Lambrecht, and this work is in progress, and I will be very grateful for your comments or suggestions, if any. Yes, here is the outline of my presentation. First of all, I'm going to tell some words about the motivation, about why should we consider the ocean. Then I'll present our model. Then I will consider two types of properties and natural resources, and then probably I will compare these two regimes of property. Well, the motivation. Why? The subtitle of our paper is Ocean Economics. Well, we consider the economy endowed with renewable natural resource, and of course, ocean is one of the important examples of the renewable natural resource. Oceans are global public goods which provide some services to the global economy, and oceans suffer from the so-called the tragedy of the commons. The tragedy of the commons means that every individual uses the resource according to his self-interest, and it happens even if all individuals know that it would be better for society not to deplete all the resources in the long. It would be better for society in the long run. However, this is a very big problem that every individual acts according to his self-interest. So there are solution for this problem. The solution is to establish property rights on the natural resource. However, in the case of the ocean, it is impossible to create individual plots to divide the ocean into certain plots like the land. It's not the land. And of course, it is also very hard to establish because of strong externality. The ocean is global resource. So this is a primary governance failure, and we consider two types of property on the natural resource on the ocean. The first type is a global government, which manages this resource, and it is the global government means that everyone in the economy can have the right to use some plot of the ocean. And our second property regime is the private property, namely we give the management of the resource to some private corporation whose shares are distributed among agents again. So we want to compare these two solutions in terms of output and some distribution dimensions. So we develop a dynamic model of general equilibrium, and as I have said, we consider an economy with a renewable natural resource and with individuals who are heterogeneous in their time preferences. Okay, let's consider the model. The output is given by the Cobb-Douglas function with constant labor, and this is the extraction of resources. The resource dynamics is given by this special exponential function, and gamma is less than 1. If gamma equals 1 and he equals 1, this is the case of exhaustible resource. And gamma less than 1 means that the resource is renewable. And now we introduce the extraction rate. This is the very important parameter for what follows. The wage rate and the price of our renewable natural resource are determined in competitive markets. They are paid their marginal productivity. Concerning the population in our economy, there are constant number of agents, L. For simplicity, this number is integer and odd, but our results hold even if it's not integer or odd. And agents have different discount factors. We order them in the descending order of the discount factors. So agent 1 has discount factor beta 1, which is the greatest in the population. Agent 2 has beta 2, which can be equal to beta 1, but it is still greater than others. So by G we denote the set of most patient agents. This set is crucial in the second type of property, economic capitalism. And we consider the simple logarithmic utility weighted by the discount factor. What about our two regimes of property? The first regime is the so-called public property, or we call it ecological democracy. That's the case of the direct democracy. The natural resource is managed by the global government, and every individual can influence the solutions of this government by voting. So in this case, one individual has one vote. We will ask our individuals to vote on the extraction rate. Yes, that's all what I want to say. And the second property regime is private property, where we delegate the management of the resource to the so-called natural resource corporation. It is owned again by agents, by their shares. And here the financial market emerges, and these shares could be traded between agents. Extraction is decided only by shareholders of this corporation by the rule of one share, one vote. And the income of the natural resource here is received only by the shareholders. And this is what we call ecological capitalism. Okay, let's turn to ecological democracy. This is the simplest case, and I'll try to explain our ideas on this example, because in the case of ecological capitalism, the ideas are just the same, but there are some technical complications, technical difficulties, which are quite difficult to explain. So, but the ideas are just the same. So, okay, ecological democracy, natural resource extraction is the only asset which is available for consumption. So here, at every moment of time, the agent consume their budget, which is given by their wage rate and the equal part of the resource income. So it means that at every time the whole output per capita is consumed by every agent, and this is true for every extraction rate epsilon t and for every sequence of extraction rate. So now we want to endogenize the extraction rate, and we want to see which extraction rate will actually be in our economy. So we consider the utility, which depends on the extraction rate at moment tau. Of course, this utility depends on the whole sequence, but at time tau we are voting only for epsilon tau, and we underline this by putting it as an argument of our function. Sorry. We introduce the notion of time tau voting equilibrium. As we say, each individual have his preferences, which are depicted by the utility function, and we can find the most preferred extraction value for every agent G. It is actually given by this very good, very important formula. It is 1 minus gamma beta G. This is the preferred extraction value for agent G at time tau. We see that this value doesn't depend on time, that is very good. It depends only on the parameter gamma and his discount factor. This value maximizes his indirect utility. Now, there is simple, one agent, one vote. In this simple framework, we define the winner as a Condorcet winner, and the median voter theorem holds. So the winner in this voting is extraction rate, which equals to 1 minus gamma beta med, where beta med is median discount factor. This is the discount factor of the median agent, which exists because L is integer and odd. But of course it exists in the general situation also. We can show that this extraction rate, this time tau voting equilibrium exists and it is unique. Yes, that's what I'm talking about. The equilibrium extraction rate is time independent. That's very important. Now we turn to intertemporal voting equilibrium. This is just the sequence of time tau voting equilibria under perfect foresight on extraction rate, but as we have seen, the expectations actually play no role in this model. That's the property of Cobb-Douglas function and logarithm utilities. Yes, there is the theorem that there exists a unique intertemporal voting equilibrium, which and the sequence of extraction rates are given by the static sequence of 1 minus gamma beta med, and the corresponding economy is built on this extraction rate. Because the resource is renewable, there exists a steady state stock, and as time tends to infinity, we can obtain the steady state resource stock and extraction rate, therefore output, and so on. And this we will compare with the outcome of our second property regime. We now turn to ecological capitalism. This is, as I have said, much more complicated case, but the ideas are just the same. Well, first of all, here the financial market emerges, and we have, first of all, to define the competitive equilibrium. In the previous case, there wasn't any equilibrium. There was just consumption. Here we have savings. And before defining voting equilibria, we have to define competitive equilibrium at given extraction rate. We introduce the value of our corporation. This is just the discounted sum of its profits at every time. And every agent solves this simple problem, maximizing his utility, starting from arbitrary time tau, subject to his budget constraint, and borrowing is forbidden. As initial conditions, we take the resource stock at time tau, and some initial distribution of shares. I will explain it later. And here, of course, under given extraction rates, we are given the sequence of extraction rate. Thus, we know the output, the wage rate, and resource rent, and there is an awful definition, but I'll explain it briefly. So we have to compute consumption, savings, interest rate as a general equilibrium framework, and the equilibrium value of the firm. So this is the maximization problem of agent. This is his budget constraint, and this is the analog of the well-known formula when savings of the previous periods equal to the capital stock in the present period. Here we don't have any physical capital in our model. However, its introduction won't change anything, just it will be more complicated to calculate all this stuff. So their savings they add up to the value of the firm. That's what you should know about this competitive equilibrium. Yes, that's what I'm talking about. And another important feature is that we use as initial conditions not savings, because savings add up to the value of this corporation, and the value is endogenous also. So the savings are endogenous in our model, and we have to use as initial conditions, we have to use as initial conditions the shares in the firm, which is the savings of each individual divided by the value of the firm at this time. Yes. There are three important issues about the previous definition of competitive equilibrium under a given extraction rate. First of all, it exists for any non-degenerate initial conditions. Secondly, if the initial conditions are such that National Resource Corporation belong only to the most patient agents, that is, to the set G, then this equilibrium is actually unique. Moreover, we know that in every such equilibrium, at finite time, under random initial distribution, for example, we distribute the shares equally among the whole population. And then agents start to trade. They start to trade with each other. And it turns out that the less patient agents will sell all their shares. And at finite time, the corporation will be eventually in this state. It will belong to the most patient agents. Unfortunately, we can't say nothing about the existence of this equilibrium, but these three important facts provide us with useful information, and there is a strong hypothesis that this equilibrium is actually unique. So let us consider the case of the unique equilibrium, and we will believe that it is unique. If it's not unique, we also manage to get the same results by some tricks, but I don't want to tell about these tricks. So here we have to introduce the voting procedure. This is just the same Condorcet procedure as in the previous case, but here we have voting which is carried out according to shares, so we have to define it accurately, but the idea is just the same. We form the preferences of agents by their indirect utility functions, and we maximize it. Here, the winner in the voting depends on the preferred extraction rates of agents and on the distribution of shares at every moment of time. A very important thing is that our proposition about the preferred extraction rate holds, and again, the preferred extraction rate of every agent is time independent and depends only on gamma and his own discount factor. We define somehow time tau voting equilibrium, and we know that if it exists, then it is unique, and the equilibrium extraction rate is given by this formula. Actually, this is very important, yes. Then we can again turn to intertemporal voting equilibrium, which is just the sequence of time tau voting equilibrium under perfect foresight, and define intertemporal voting equilibrium. And this is the characteristics of our intertemporal voting equilibrium. It starts somehow with initial distribution. Then we don't know the sequence of the dynamics of the distribution of shares, but we know that finally, from some finite time, all shares will belong to the most patient agents. So from some time, the equilibrium extraction rate will equal 1 minus gamma beta1, because the owners of the shares will vote unanimously for their preferred extraction rate. And this means that in the steady state, the equilibrium extraction rate will be just this one. And for steady state resources and extraction, we have the same formulas, but instead of beta med, here stays beta 1. And let us quickly compare two regimes. If agents are homogeneous, that is, their discount factors equal, it means that the two steady states are totally the same. And there is no difference between public and private property regimes. But if agents are truly heterogeneous, then we can show that the steady state volumes of extraction and extractions per capita are increasing in the discount factors. So if they are heterogeneous, then the discount factor of the most patient agents is greater than median, and the output, therefore the wage rates, would be higher. However, that doesn't mean that the consumptions of all agents will increase, because in the second case of ecological capitalism, the redistribution of income takes place, and yes, what I wanted to say, the redistribution of income takes place, and they consume only their wage. So, as we have seen, the economy in the case of private property is wealthier, but exhibit income inequality, and there is a trade-off between inequality and wealth. Yes, that's all. Thank you.
Thank you very much. Are there any questions?
A very quick question. Do you think you could generalize your two models so that there's a model that covers both, but both come as special cases of the same model?
Yes, I think I'll get your point, because they're the two cases, democracy and capitalism, they are a bit the same. That is the governance of the individuals, but the capitalism is more indirect governance through the corporation. I think that there is some ways to generalize this model, just because they are quite the same, but I don't know how to make it clearly.